This video is on measurement. So there are a couple of different measurements that we're going to talk about today. The first one is length. So the length is how long or wide something is. We measure it using a ruler or a meter stick, and so it doesn't have a formula. Its symbol for length, we usually look at length as L for length. The units for length are typically in meters, although frequently we will use centimeters. So we put the C in front of the M to make centimeters. The little m in front of the M is millimeters, and the K is kilometers. So if I have something, a line drawn here, and I want to measure its length, I'm going to measure from one side of it to the other side of it. And this distance between each end is the length, which we will label L or a capital L. Tools to do this would be rulers. We will use the centimeter side, or we could use a meter stick if we had something pretty large. Our next one is volume. Volume is a three-dimensional dimension, and the volume is the space that something takes up. Volume we typically show as letter V, and our formula for volume is length times width times height. So volume equals length times width times height. We can also use water displacement to figure out volume, which we'll talk about in a little bit. The units for volume are liters, or if we were using length times width times height, we would get centimeters cubed. Instead of using liters, we typically use milliliters because that's something we can measure more easily in the lab. If we had a block, we could measure its width, and that could be any one of our sides. So the width side, the length side, and the height side. Okay, any one of these. Doesn't matter which one, we just want to take all three of our different sides, measure those, and multiply them together to get our volume. We can use a ruler or a graduated cylinder to measure volume. We can measure liquids using the graduated cylinder. We can measure the volume of a block using water displacement in a graduated cylinder, and we'll do that in class today. Mass has to do with the weight of something. Okay, weight has to do with not just the mass of it, but also its density and the gravitational force upon it. Okay, so we kind of use weight and mass interchangeably, but really they're different. But for our purposes, we'll consider weight basically mass. The mass can be measured. Okay, we can't calculate it. In mass, we give the little symbol m. Mass is usually measured in grams, but again, because it's a metric unit, we can have milligrams or kilograms, milligrams being small, kilograms being big. You might have heard of something like a kilo of something. That is kilograms. Okay. Here's my picture of mass. So just the space that an object takes up and then its gravitational force going down. Okay, we measure that using a scale or a balance. We'll use scales that are electric, but you could use a balance by putting weights on one side of a known mass and then seeing how many you need to add to even out the other side. Another measurement we'll take is temperature. Temperature, commonly thought of as how hot or cold something is, really isn't true. Temperature is a measure of the average kinetic energy of molecules, or how fast molecules are moving. So if something has a high temperature, it means its molecules are moving super fast. Something has a low temperature, molecules are moving slow. That's why solids are at low temperatures and gases are at high temperatures, because gas molecules move all around, whereas solid molecules just kind of vibrate in place. Just like our other ones here of mass and length, temperature is a measured value, and we use our symbol of a capital T to represent temperature. Its units are typically Celsius. We don't use Fahrenheit in chemistry, we use Celsius, and we could also use Kelvin, and we'll get to that form of unit later on. So we could add that we also have Kelvin, which we represent by a capital K. We'll use thermometers to measure our temperature of something. You could either have a analog thermometer, where you'd have to look at how far up the liquid goes, or an electric thermometer, which we would just have a probe at the end and it would tell you the temperature of it. Finally, we have time. Time is how long something takes. Again, that's measured, and we show time with the lowercase t. We'll measure time in seconds. Okay, so we'll use a clock or a stopwatch or a timer to measure time. Typically, we'll use the timers on your phone if we need to measure the time of something. So these are our different measurements. Now, how do we actually go about measuring? Two different ways we could measure. We could use a ruler or a graduated cylinder. So with a ruler, we'll write down what we see, and then we're going to estimate 1 decimal past what we see. So if I have this line here, I'm going to take my ruler. I'm going to use the centimeter side of my ruler. I'm going to line it up with the edge, and I look down. Oops. And I can see that my line goes past the 8, but doesn't quite get to my next little tick mark. And if we look on our ruler in centimeters, every tick mark is 1/10 of a centimeter. So this is 8 and 8.1. I can read for sure that it's at least 8 centimeters. But because we have brains, we can see that it's a little more than 8, but a little less than 8.1. So I could say that I know that it's exactly 8.0, because those are what we can see. We know the tens place because we can read the tens place. And I'm going to estimate one more. Let's say it's about 8.05 because it's about halfway-ish between my 8 and my 8.1. Now you might look at this and say, Ms. D, it's not in the middle. It's actually closer to the 8. So you might say that it's 8.03. Okay, so we can agree upon that it's at least 8.0, but our ending number is going to vary a little bit. So this is our number of uncertainty. And that's okay because we're going to have a little uncertainty in our measuring devices. So it's important that we read what we can see, and then we estimate 1 past what we can see. So we know it's at least 8.0, and then we estimate 1 more past that. Okay. We can do the same thing with a graduated cylinder. When we measure using a graduated cylinder, we measure from the bottom of the meniscus. So water inside a graduated cylinder is, because of its adhesion and cohesion forces, are going to get stuck to the sides. They're going to cling. And I'm going to get this little dip in it. And this dip is called a meniscus. We read from the bottom. So my bottom meniscus is about here. And if I line that up with these are graduations or my tick marks along the side, I can see that it ends up just under this mark here, but just over my next mark down here. So it's somewhere kind of in the middle. So in fact, if I make a mark, it's right there. So if I look at this graduations on here, similar to my graduations with my ruler, I have 9, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 graduations or tick marks in between. So this again goes up by the tens place, so 9.1, 0.2, 0.3, 0.4, 0.5. I know it's at least 9.5. And then I'm going to estimate 1 past it. I know it's not 9.6, but it might be a little bit more than halfway, so I might say it's 9.56. And our graduated cylinders will measure in milliliters. Okay, what we forgot up here is this should say centimeters after it because that's what we measured in. And so we'll practice that in the lab by looking at different graduated cylinders or beakers or rulers and meter sticks just to see what are measurements that we can get from them, always saying what we know and then estimating 1 past it.